Okay. So for the most part, on these reviews, I put the formulas and equations on here that you're allowed to have on your cheat sheet as well. So anything written above them, you can have this, complex form, conjugate pairs, all that stuff you can write on your flashcard. So this section is regarding complex numbers. So you will do some math with the complex numbers on your exam, either adding them, maybe multiplying them, definitely dividing them. So let's just review how to do that. Remember, anytime we see a negative underneath a square root, that is what creates those complex numbers. And so the first thing I would want to do is rewrite in terms of I. And simplify the radicals. So I'll leave it like it is, and I'm just going to simplify the radicals. So how would I rewrite the square root of negative 16? 4i. The square root of 16 is 4, and because of that negative under there, that becomes the I, because that's the same thing as, let me write it up here. This is the same thing as the square root of negative 1 times the square root of 16. And the square root of negative 1 is I based on this. So this is I, and the square root of 16 is 4, because 4 times 4 is 16. And we just usually write it like that. And then the square root of negative 25 would be what? 5i. Because the square root of 25 is 5. And that negative is what creates the I. Now we just add like terms, because that's what it's telling me to do. Add them. And so I can just add the real numbers, 3 plus 2, which is 5. And then 4i minus 5i, these are considered like terms. And 4i minus 5i is negative 1i. So I could just write minus I. And this would be the answer. It's already in the complex form because the real number is written first and then the imaginary part is written second. You want to make sure you put it in that order. All right, number 2 is 3 divided by 2 minus 5i. So when we divide complex numbers, I need to multiply the top and the bottom by its complex conjugate so that I can get rid of the imaginary number in the denominator. So we will multiply the numerator and the denominator by the complex conjugate of the denominator. So the denominator is 2 minus 5i, so what would the complex conjugate be? 2 plus 5i. Just change the sign in the middle. This one was negative, so this one would be positive. So on top, I'm just distributing that 3. 3 times 2 plus 5i. So 3 times 2 is 6. 3 times 5i is a positive 15i. And on the bottom, I have to FOIL, but if you remember that little shortcut I gave you, if you ever multiply A plus BI times A minus BI, these are two complex conjugates, it's just equal to A squared plus B squared. So I could use that little shortcut, and you could put this on your formula sheet. So A in this case is 2. 2 squared is 4. B is the number in front of I here, which is 5. You just forget about the plus and the minus. It's just 5. 5 squared is 25, so this would just become plus 25. So this would be 6 plus 15i over 29. Now, the last thing I need to do is write this in complex form by separating it into two fractions. Remember, we did that. So I take the 6, I divide it by 29, plus the 15i divided by 29. This would be my final answer. Nothing else can be simplified. Good? All right, the next section is solving quadratic equations. So, I really hope by this point, we're good with this. Hopefully. But if not, if you don't have this down like that, you could write all of this on your flashcard. I don't care. But there's the quadratic formula. That always works. That'll always solve any quadratic for you. And you have to use that when it can't be factored. And then the other techniques there, I have get the equation equal to 0 on one side, and then factor out a GCF if possible. And after you do that, if you still have 3 terms, or if you have 3 terms, you want to factor using the AC method, which is multiplying A by C, finding 2 numbers, multiply to give you A times C. And you could even put those steps on your flashcard if you want to. Just can't do an example. Or maybe it's a difference of 2 squares, so then you need that difference of 2 squares formula, which is A plus B times A minus B. But you can also solve those by using the property of the square root and just get x squared by itself. And then take the square root of both sides, but then you need to remember the plus or minus rule of that square root property. Look for sum or difference of 2 cubes. You won't have that on your exam, so you don't have to worry about that one. And then 6, like I said, you can always use the quadratic equation using the quadratic formula. Number 7, you will definitely have one of these on your exam, so make sure you know how to do this. If the equation is quadratic in form, then we need to use substitution and then solve one of the methods above. Okay? So there's an example on here we'll go over. All right, so this example here, this is a quadratic. The first thing I'm going to do is get it equal to 0. So I'll subtract 6b over to both sides to cancel it on the right. And so this would be 2b squared minus 6b equals 0. Because those are not like terms. I can't combine them. So I just write it like that. And then this one is only 2 terms, and they have a GCF. So I can factor out the GCF of 2b. That's my GCF. They both have a factor of 2b. So if I factor out 2b, that leaves me with 1b in the first term minus 3. Right? Factoring out a GCF. That's what I just did. And then I set each factor equal to 0. So 2b equals 0 or b minus 3 equals 0. So on the left one, I would divide both sides by 2. And b would just be equal to 0 because 0 divided by anything is 0. And on the right side, the right equation, I would add 3 to both sides, so b would just be equal to 3. So I have two solutions to that equation. And again, you can plug those back in and check on your test to make sure you did it right. But you don't have to. It's not mandatory for quadratics. That would be the answer as long as you did your work correctly. Any questions about that? And I'll just put this note, we factored out the GCF, in case you want to refresh on how to factor out a GCF. Okay, number 4, use the quadratic formula to solve the equation. So this is 3x squared minus 7x equals 1. So before I even use the quadratic formula, I also have to get it equal to 0 on one side. So I'm going to subtract that 1 to cancel it on the right and bring it to the left. So that would be 3x squared minus 7x minus 1 equals 0. And now I can identify my A, B, and C. So A would be 3, B would be negative 7, and C would be negative 1. And so plugging it into the quadratic formula is negative B. So because b here is already negative, that would just change it to positive 7 plus or minus the square root of b squared, so negative 7 all squared, minus 4 times a, which is 3, times c, which is negative 1, all over 2 times a, which is 3. And then I'll simplify. So 7 plus or minus negative 7 squared is 49. Negative 4 times 3 is negative 12, but negative 12 times negative 1 is a positive 12. Oops. So that will become plus 12 all over 6. And 49 plus 12 is 61. So that'd be 7 plus or minus the square root of 61 over 6. And 61, I believe, is a prime number, so that will not be able to be simplified. But you would always want to check to see if 61 can be divided by any of those perfect square roots so that you can simplify that radical. And of course, if there is a negative under there, you would write it in terms of I. But this can't be simplified. So this would be my answer. 7 plus square root of 61 over 6, and 7 minus the square root of 61 over 6. I don't need to separate these into two fractions because they're not complex numbers. You only need to do that when it's complex numbers, when there's an I. But there's not an I. And I believe you could have just written it like this in the answer, plus using the plus or minus, and then you would have been fine. Because it's not complex. Good so far? Okay. All right, last one for the quadratic. This is the one that's quadratic in form. Because this larger exponent of 4 is 2 times the smaller exponent. 2 times 2 is 4. So this is the one that you'll have on your exam. I mean, not exactly, but your highest exponent will be 4, and the smaller exponent will be 2. Okay, you won't have any other exponents on this one. But this is quadratic in form because it's ax to the 2n power plus bx to the n plus c. It's double. So the first thing I'm going to do is get it equal to 0, so it can actually be in this form. So I'm going to subtract 14 to both sides. So that will leave me with x to the 4th plus 5x squared minus 14 equals 0. And then I'm going to use substitution. So I can put it in quadratic form that I'm used to. So my smallest variable or exponent there is x squared. So that's what I will let be t. And if t is equal to x squared, then t squared is equal to x to the 4th. Because if I square both of those, I'll get x to the 4th on the other side. So therefore, this can be replaced with t squared, since I just said t squared is x to the 4th, plus 5t minus 14 equals 0. So now this is a regular quadratic in the form of a regular quadratic. And this will factor. I need two numbers that multiply to give me negative 14 and add to give me 5. So that would be 7 and negative 2. And now my variable is just t, so this would be t plus 7 and t minus 2. And then what you do now is you set each of these equal to 0 and solve just like normal. So t would be equal to -7 and t would be equal to +2 after I set those equal to 0 and solve. And so the final step would be to back substitute. I said t was equal to x squared. So I need to put x squared back for t now. And finish solving these. So I'm going to go up here. So for x squared equal to -7 and x squared equal to 2. So now I would take the square root of both of these to finish solving for x. Because I need to get rid of that exponent of 2. So that would leave me with x equals plus or minus the square root of -7, which would be plus or minus I times the square root of 7, because of the negative underneath the square root there. And the other one would give me plus or minus the square root of 2. So I have 4 answers. And that would be my final answer. Okay.
Are you going to be here after 12:15?
Okay, number 6. This says the formula S equals 16t squared is used to approximate the distance S in feet that an object falls freely from rest in t seconds. The height of the building is 1,325 feet. How long would it take for an object to fall from the top? Write your answer as an integer or a decimal rounded to the nearest thousandth. Okay. So this one isn't that bad. It sounds crazy, but it's really not that bad. They tell me that S is equal to the distance in feet that an object falls freely from rest after t seconds. So that's the distance. Like if I dropped it from rest, how far will it fall? How far would it have fallen after t seconds? So after 5 seconds, I would plug 5 in for t, and that would tell me the distance from where I dropped it to where it's at 5 seconds. And then they tell me the height of a building is 1,325 feet. So they're standing at a building. Here's my building that this person's standing at, and the height is 1,325 feet. That's how high it is from the ground. How long would it take for that object to fall from the top? So they're going to drop the object, and it's going to drop down to the bottom. And they want me to find how long, which means I'm trying to solve for t. I don't know t, but I do know the distance that they're dropping it. They're dropping it from 1,325 feet. And that is what S represents, the distance. So all I need to do is plug in 1325 in for S. And then solve for T. Does that make sense?
You said plug S in for what?
Plug the 1325 in for S, because that's the height of the building that they're dropping it from, which means the distance from where they're dropping it to the ground would be 1325. So I would divide both sides by 16 here to get T squared by itself. Write your answer as an inner decimal rounded nearest thousandth. 1325 divided by 16 is 82.8125. I'm not going to round it yet until the very end. But this is what I got when I divided the 1325 by 16. And now I can just solve for T by taking the square root of both sides, right? That's how I get rid of that exponent of 2. Now, in this case, I don't need to worry about the plus or minus because I'm solving for time. Time can't be negative. So you just need to be aware of your application. Obviously, we're not thinking of negative seconds. I mean, I don't even know what that means. So I'm only interested in the positive answer. So T would be equal to square root of that, rounded to the nearest thousandth, would be 9.1, really just 9.1 because it's 9.10013. So I'll write that out though, 9.10013, blah, blah, blah. The thousandths place is this 0, and the 1 behind it tells me to keep that the same. And so that'd be 9.100, but I don't need the zeros. So this would be after 9.1 seconds, that object would hit the ground from that distance of 1325. Okay, since we leave at 10:45, right? Yeah. Okay, I'm gonna skip to this problem here real quick because I want to do that with you guys first, but it's going to be using this information, or I want to do that problem with y'all before you leave. So remember, for a quadratic function, we can find the vertex using this as the ordered pair, the axis of symmetry, and we know that if the A in front of the quadratic is positive, then it's pointing up and it has a minimum value, and if it's negative, it's pointing down and it has a maximum value, right? So this problem says a ball is thrown directly upward from a height of 5 feet with an initial velocity of 28 feet per second. And the function here gives the height of the ball in feet t seconds after it has been thrown. Determine the time at which the ball reaches its maximum height and find the maximum height. So he's standing on a building that's 5 feet tall. He throws this ball directly upward, and it's going to go up, 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 and it's going to come down like a parabola. And so the maximum height would be up here, which would be the vertex of this parabola, right? That point where that ball reaches its maximum height is the same thing as the vertex of this function. And this is a quadratic function. Where a is negative 16, b is 28, and c is 5. So if I wanted to find the time at which the ball reaches its maximum height, I would be finding t equals negative b over 2a, because this gives me the x coordinate of the vertex. So I could find that. I could find the time where it reaches the maximum height. So you want to think of like your x-axis as the time here. Your y-axis as the height of the ball, or s of t. Okay, so this would be negative 28 over 2 times negative 16, because I'm just plugging in a and b for this. And negative 16 times 2 is negative 32. And this would simplify to positive 7 over 8, because 4 can divide into both of those. And it probably would have you round this. To the nearest hundredth of a second, so this would be 0.88 if you rounded it to the nearest hundredth. So that's the time that it would take to reach its maximum height. So here at t 0.88 seconds, it's reaching its maximum height. And then, of course, I could plug this time back into the function, the original function, to find the maximum height that it would reach using my calculator. So 0.88 squared times negative 16 be negative 12.3904 plus, you can plug this entire thing into your calculator at one time as well, 24.64, and then plus the 5 gives me 17.25 feet rounded to the nearest hundredth. So this would be the maximum height that the ball reached. Okay, and I will stop there and record a second part 2.